Alright, so we are going to attempt to repair this power supply, and we are going to start our adventure here with desoldering these totally worked out solder joints. So they are heavily, it's damaged the trace underneath it completely. I'm going to get rid of that. Alright. Yep. Alright, so in order to do that, I'm going to have to really get in here. Add a little flux. Solder, it seems. I don't know what solder this is. These traces are totally damaged. Okay, so we're back and I've gone a little further. I've actually removed the connector. Now, that, and I have cleaned the, using a Dremel and a 220 grit sanding disc. I have removed the conformal coating, the green conformal coating over the everything. And of course, you know, what we're seeing here is, you know, I don't know if you can see that, but you know, we've got the copper worn away. Now, the thing that you're going to also probably be interested in knowing here, and I'll show you these, are these things, these little inserts, these posts that it inserts, or that the manufacturer inserts into the board to provide some extra resiliency to the board from these connector prongs that, of course, what I've done there is I've taken a diamond tip or a diamond tip little cylinder, and I have gone and cleaned those out on the inside. They were really badly oxidized, And then I went ahead and followed up by placing them on the pin and cleaning them off. Now what I'm going to do here is use the Dremel with a steel brush, stainless steel brush, to clean out all the oxidation. Oxidation and soldering. Oxidation is solder's worst enemy. It will prevent proper wetting. It will create cold solder joints, which is likely to have been the original problem, as well as the compounded problem. It also can create conditions that like tin whiskers, which will can over time, carrying large currents, can actually bridge traces and solder gaps and stuff like that, and create all kinds of mess. So now what I'm going to do here is I'm going to load each of these up onto onto the soldering iron and clean them off in the tip cleaner and tinner. And what that's going to do is that's going to guarantee that I've got a good coating of solder on the inside and outside edges of these posts, because that's going to be necessary to properly connect those to the board. And the way that you would ordinarily do this is you would poke them through from the top side, but because I've got this this gap here, what I'm going to do instead, I'm actually going to drive these through from the back side. And what that's going to get me is going to get me the hole that's basically the same size. It is the same size actually, but what that's also going to do is that's going to let me place these. There goes the trouble. Just going to go ahead and do this the easy way. Save ourselves a minute. Oh, there we go. It goes. Always risk losing them. We're going to take these and clean that off, tin it up in the tip cleaner and solder, or the tip tinner solution, and then we're going to just go ahead and drop that in there, right on the ground prong. Okay, and last but not least, go ahead and grab that on there. Okay, and into the cleaner, tip tinner and cleaner, and back out and down into that hole. So now what we're going to do, take our cleaned and put a little bit of cleaner on there. Clean it up. A clean tip is essential for properly soldering anything. You should always clean your tip regularly. I try to clean it in between every solder joint, just because it's just that much more likely to successfully solder. Now, because I've tinned these a lot, I'm going to take a desoldering wick here, move that to the side, and just lay the wick in place, get any excess solder off of there, because, of course, that excess solder is likely to make it very difficult to get that through the hole. I'm going to go ahead and kind of wedge that underneath that protective glass. Let's see if we can try that again. And there we go. Give us a little bit of play, resistance to movement, and get that nice and hot. that makes sure that those pins are nice and clean. So now what we're going to do is we should have little to no problem gently putting that in there, and getting everything nicely aligned. And what I'm going to do, make sure our little pins here, our little grommets are fully engaged. Push that down, and then make sure you can see that. And we're going to apply a little flux, because flux is the key to soldering. It really is. If you're going to make a successful solder joint with any electronics, you must flux the joint. You know, a lot of these solders have flux built in, but that's never a guarantee. Never a guarantee. Now I'm going to put an overabundance of this on here, and why I'm doing that is because, of course, when we remove that conformal coating, then that is prone to oxidation. So we must thoroughly wet every bit of this. All right. And we're gonna go ahead, make sure we've thoroughly wetted all this and covered all of the copper, as much of it as we can anyway. There we go. It's going to be a nice strong mechanical joint as well as a strong connection. And we'll sit there and patiently wait for our solder to dry correctly. And then, of course, the other thing that most manufacturers do neglect is to properly wash off your flux, because of course flux is corrosive. That's how it works. So we use an alcohol wipe to thoroughly clean our solder joints, and you will notice then that our solder joints are nice and shiny. Those are lead-free solder joints, so they are not quite the same shininess as others, but I imagine that it would be just fine. So what we're going to do now is we're going to double check. We're going to run first a continuity test on our newly minted solder joints. So we'll take our meter, just run a quick continuity check. Probes are in the wrong spots. Might help if I do that. Check. There we go. And so we go upstream. We got that one's good. We check a ground, preferably a bit away. Oh, that looks good. Nice solid connection. And we go upstream, and that's nice and solid. Great. All right, so now that we've got that done, our next step is first we need to do that dreaded testing. So what we're going to do to accomplish that is we're going to take an IT power cord here, which we have a number of, and I'm going to go to my trusty switch here, which will help. It's got a remote switch, so we're gonna turn off everything and make sure. Oh, actually, you know what? I'm gonna make sure before I do all that, we're gonna put on our supporter, which is probably a good idea. So before we continue, we are going to. There's this little this little strap here that they put across that to further reinforce the it's gonna get kind of hot. So we should grab the hemostats and hold on to that. So we just need to go back and clean that off a bit and make sure we're clean and do ourselves a bit of a favor and straighten those out. You want to install these because, of course, this is half of what the problem began with, was insufficient support. Alright, so we're going to go ahead and install that strap here. Come on now. There it is. And turn that around. Pull that up. And cock that over according to the diagram here on the board. Thank you. Now, one of the other things that I'm noticing is that, I don't know if you can see this, but you have a crack in the board here. That could be problematic. This does not appear to be a multi-layer board. In fact, all we have to do is hold, yeah, it's not. I mean, we've got, yeah, it is not a multi-layer board. We can tell that by simply shining a light through it. We're just going to check our solder, our joints. So, looks like we've got, there's a there. Let's see, let's go into that. All right, so we've got a jumper. Oh, there we are. There's our blue jumper there, J3, which we see on the other side of the board is that black line right across there. So that's fine. It does not appear that that crack's going to affect anything, so we're good. And there you go. So we're going to put this back up here. Hopefully you can finish watching. Okay, so we need to get that other strap in there correctly. Nice and steady. I'm gonna do this a little bit off camera because of course I gotta really jam it down in there. So we're gonna, come on now. There we go. Got that bent in. And then we went the wrong way. Fantastic. Alright, now obviously the trick with these straps here, these act as additional grounds as well as mechanical support, so we're going to go ahead and lay in a tiny bit of solder there just to help reinforce everything nicely. There we go. And we'll be real liberal with that, make sure it heats up correctly. That's nice. Alright. And then again on this side. Wait for it to wet properly. Perfect. Now, not sure about how we want to address that. I think, since we have this board cracking here, and I know it was cracking right there too, what I'm going to do is I'm going to elect, so we don't have any copper there, we're going to take a little bit of our lovely trusty 5-minute epoxy, just a little squirt. Very good. And we will mix a tiny bit of that up. And what we're going to do is we're going to reinforce that board right there. And there we go. And again on the other side. Yes, indeed. And that's our neutral line, or neutral wire. So we are just going to reinforce that here. Hopefully you can see that. And that will help. It looks like we need a little bit there at the ground prong too. So we're going to reinforce that on the upper side primarily because we don't want to interfere with the ground trace, which would certainly happen. And a little pro tip about 5-minute epoxy is that it is, as long as it is liquid, it is readily soluble in alcohol, isopropanol. So you can use that for a quick cleanup while it's not solid. There we go. All right. So where we are now, I think is we're just going to do a quick initial test. Now, if it had arced over as radically as you had mentioned, then it seems that we would see some more damage on the board. But we're going to go ahead and put this up here onto our trusty, busty glass piece, just to make sure if anything goes awry. And now I'm going to attach this to our power, double checking that it's off, of course. We're going to attach that to power carefully. Now, moment of truth. Here we go, 1 and 2. Power on. That appears to be all right. Okay, so it at least appears not to be arcing, which is the most important thing. So the next thing that we want to do is we are going to verify our power is off. It is. We have a good ground. It does. All right, because this is a high voltage supply, we will want to be incredibly careful. So next, we are going to check our fuse, because you did say that it blew its fuse. So we're going to pull that out, check that for continuity, and it is bad. Okay. All right. 3.15 amp fuse 1. All right. Well, we're going to go find a fuse, and I will be back. All right. Just wanted to get you all set up so you can see this. So, as I had mentioned, what we're going to be looking for now, we've got a fuse in there, and we're testing it for power. So what we're going to do is we're going to bridge between the ground here. Very, very carefully check for 5 volts, which is exactly what we get there. And we're going to check for 12 volts there, which we do not get. Okay. Just not sure if we need that or not. You know what, actually, now that I'm thinking about it. So let's see, what do we got between the power supply on pin and nothing? So I'm going to suggest that a 5-volt power on that will power up our power supply. So we're going to unplug it, and I'm going to grab me a jumper here. There we go. Put one from the Arduino. Should be fine. And I'm going to bridge between 5 volts. First of all, so the bridge between there. I don't know if that's going to work. Let's see here. I think the red wire might not work at all, so I have to do a little bit better than that. All right. So let's take a look at our schematic here again. DPS-120 RP. So it looks like power supply on off. Switch. So we are going to need well, here, you know what? Let's just go ahead and push that into here. I'm going to pull this out of its mount. See if we can give this a little bit more tension here. But we do have 5 volts coming through our SB. We're just going to put a little tension on this spring. I'm actually going to go ahead and pull that out. Now, since the potential between our ground prong and PS on is 0, we're going to go ahead and first we'll try grounding that out, because usually or frequently, I mean, that's like the ATX power supply spec states to ground it. We're going to ground it first, see what we get on that 12 volt, and go from there. Okay, so let's give it a ground and go here. Now I'm going to take that ground and we're going to go against the 5 volt. Still got 5 volts. Do we have 12 volts? We do not. So now let's try applying 5 volts, which is a logic level input. Should be safe. And is commonly what, you know, barring anything else, you would see that. Alright. Here we go. And we have power. Let's check our ground 12 volt connection here. And we have 12 volt. Oh, we have 7 volts. Yeah, that's better than nothing. Okay. Well, a little bit shy on that, but that could be many things. But I am going to go ahead and say that this is at least in better shape than it was. So hopefully that will work for us. We definitely have a good stable 5 volt, which hopefully will power up the scaler. And we'll go from there. That could be a dimmer, that could be any number of things, but we will find out. But needless to say, the power supply is functioning. So there we go. I'm going to clean up this fuse connection and go from there. See you soon.